this lecture, we will solve the exercise 1.1 in chapter 1 number systems. Before we do that, I will take you through one more example of finding rational numbers between any two other numbers, especially negative numbers. Let's see what will be the case if we having negative numbers. So in the textbook and in most of the problems, I have not seen negative numbers in these kind of problems, but it is good to have an understanding of what will happen if there is a negative number. Will there be any surprises for us, or it is a normal or usual procedure? Okay, so for that sake, I thought it is better that we at least go through one example and let's make ourselves very comfortable in facing any kind of problems from this chapter. Okay, so the first question, or the third example, as I would say, so this is not given in the textbook, this is something I have created myself just for all of us to have an idea of dealing with negative numbers. So this goes like, find 4 rational numbers between -3 and -4. We have the solution 1 method that we used in the previous 2 examples to solve the problems. So what have we done? We found rational numbers by using the formula r plus s by 2, and r and s was the two extreme numbers. So in this problem, r is, we can take it as -4, okay, and ss. So why r is equal to -4 and s equal to -3? So we have a number line, okay, and the positive numbers will be increasing towards the right side, right, and we have negative numbers in the left side. So let me note negative numbers and I will change the color. So this is -1, and this is -2, and -3, and -4. So in this problem, we are trying to find rational numbers between -3 and -4. Okay, so that's the reason I took r as this and s as this. Okay, so straight away we can try and solve the problem. So r plus s by 2, we just have to apply the same formula. So -4 plus -3 by 2, you will get -7 by 2, or this will be -3.5. okay, next thing I can find it as, so this is, I would say, the first number. The second number, again the same formula, r plus s by 2, but here we change the r and s. So let us say I use the same r, -4 plus, and for s I will use this. So it is -7 by 2 by 2. Okay, you will get -15 by 4. Okay, -15 by 4, if you actually calculate, it will come to be, when you calculate, you will get -3.75. So we have found two numbers. For finding the third and fourth, I'll leave it as an example for all of you to practice. You can do the same way. I will write the formula for the third also. So third, r plus s by 2. Okay, this time I will use r as this, and s as -3. Okay, so r is -7 by 2 plus s, I am using it as -3 divided by 2, and you will get -13 by 4, which will come to be -3.25. So this 3.5 will come exactly between -3 and -4. This 3.75 will come somewhere here, and this 3.25 will come somewhere here. So similarly, you can find one more point. I'll leave it as a practice problem for all of you. I will now solve the same using the solution 2 methodology. In solution 2, we were basically trying to transform the both extreme numbers in the form of a fraction. Okay, so in this problem, we had the two extreme numbers r equal to -4 and ss -3. Okay, so how can we transform this? So we need 4 numbers, right? I need 4 numbers between r and s. So this is how I will transform. I take minus 4, I will multiply by 4 plus 1, and I will divide also by 4 plus 1. Okay, then we have numbers in between the two, and the other number minus 3 into 4 plus 1 divided by 4 plus 1. So if I actually calculate, I will get minus 4 into 5 minus 20 by 5, and numbers in between, and minus 3 into 5 minus 15 by 5. We can now easily write the numbers. It will become minus 20 by 5, and I add plus 1 to the numerator, so I'll get minus 19 by 5 minus 18 by 5 minus 17 by 5 minus 16 by 5 and minus 15 by 5. So this 1, 2, 3, 4, all these numbers will lie between minus 4 and minus 3. So through this example, we can understand that the same methodology can be applied even in the case of a problem when we are dealing with negative numbers. Okay, now we will move to the exercise problems in the textbook. Before we go and solve the exercise problems, I think it is very good to take some time and recollect what are prime numbers, what are composite numbers, and what are coprimes, because these are something that every one of you have to be very familiar with, and it is expected that these things come to your mind by default whenever you are going to see these terms. Let's say you are writing CBSE 10th board exam, and it is highly expected that you are going to encounter these terms like prime numbers, composite numbers in your question paper. So at that time, you don't want to be in a position of confusion, right? Like you are reading the question paper, you encountered the term prime number or composite number, and then if you have the slightest of the doubt of what is a composite number, then you will not be able to proceed further in solving the problem. So let us take some time to briefly recall what are these. Let us cement this knowledge so that in future whenever we come across any of these, it is very clear for all of you and there is not even an iota of doubt. So what are prime numbers? It is nothing but a natural number greater than 1. Okay, and it has exactly two distinct factors, the number 1 and the number itself. In other words, it cannot be divided evenly by any other number except 1 or itself. So what are the examples? Of course, it is only going to be positive, and these are natural numbers. And couple of things that you can keep in mind: 2 is the only even prime number that we have. There is no other even prime number that you can see, because if there was an even prime number, then it will be divisible by 2, and then it will violate the law that defines what is a prime number. So 2 is the only even prime number, rest all are odd, and 2 is the smallest prime number, and 2 is the smallest even prime number, and 3 is the smallest odd prime number. So 2 is the only even prime number that we have, and let us look at a couple of examples. So what are the factors of number 13? 13 is a prime number. It is nothing but 1 and the number itself, which is 13 here. And the next one, what are the factors of number 131? So the factors are nothing but 1 and the number itself, which is 131 and 1 here. So this is nothing but prime numbers. Let us move forward. What are composite numbers? Composite number again are natural numbers greater than 1, but now it has more than 2 factors. So it can be divided evenly by numbers other than just 1 and itself. So we have factors 1 and the number itself, and beyond that we have more numbers which are factors of the given number, and such kind of numbers are called as composite number. Let us go through some examples. Let's say 4. 4 has factors what? 1, 2 and 4. 1 and 4 are the obvious factors that we have, and additionally we have 2. That means we have factors more than 2. So 4 is a composite number. Let us look one more example, 9. So 9 has factors 1, 3, 9. 1 and 9 are obvious, and beyond that we have 3 as a additional factor for the number 9. So 9 is again a composite number. Again 117. It may feel like it is a prime number, but it is not. It has several factors 1, 3, 9, 13, 39, and the number itself. Again 117 is a composite number. So 1 is not a prime number. We do not consider it as a prime number, and 1 is also not a composite number. There are some questions which says something like this: consider the smallest odd prime number. In those scenarios, all of you should not consider 1 as smallest odd prime number. The smallest odd prime number will be 3. It is not 1. Okay, the smallest odd prime number is 3 and not 1. Many questions have statements like consider the smallest odd prime number, and it should be 3 that you have to consider. Let us move even further. What are coprimes? We saw coprimes in the first lecture when we were studying about rational numbers and representing rational numbers in its smallest form. So in that case, the rational number p by q in the smallest form can be obtained when p and q are coprimes. It is basically pair of numbers. Okay, it is not a single number but a pair of number whose greatest common factor is 1, or the highest common factor is 1, or the HCF is 1. Okay, in other words, they do not share any factor except 1. So there is no common factor other than 1 between these two numbers, and they are also called as relative prime numbers. Please make a note of this, because again in some questions it is referred as relative prime numbers, because in some questions the sentence goes like consider relative prime numbers. Okay, in such scenarios you have to understand that it is being referred to the coprimes and not to the prime numbers. So relative prime numbers is the same as coprimes and it is not the prime numbers. So let us look few examples. 4 and 9. Again 4 has factors 1, 2, 4 and 9 has factors 1, 3, 9. And what are the common factors between 4 and 9? It is just going to be 1. We can say that 4 and 9 will form a coprime. Let us look one more example, 21 and 22. 21 has factors 1, 3, 7 and 21. 22 has 1, 2, 11. And what about the common factors? The highest common factor between the two is 1, or the HCF of 21 and 22 is 1, and so 21 and 22 will form a coprime. And last, any two prime numbers are coprime to each other. Okay, so in this case we saw that 4 and 9 are coprime, but 4 and 9 are not prime numbers, but together they form a coprime. 21 and 22 are not prime numbers, but together they form a coprime. But let's say we have two numbers a and b, and both a and b are prime numbers, then they definitely form a coprime. We will see one example, 311 and 313. Both these numbers are individually prime numbers. 311 is a prime number, 313 is a prime number, and together they form a coprime. So any two prime numbers are coprime to each other. That is a guaranteed thing. But we can also have a situation that the individual numbers are not prime numbers, but together they form a coprime. Why? Because the only common factor between the two is 1. The first problem is 0 a rational number? Can you write it in the form p by q, where p and q are integers and q not equal to 0? So I have already answered this problem during the previous lecture while explaining the different kinds of numbers, but nevertheless we will quickly go through the same problem. Basically the answer to this question is yes. That is 0 is a rational number. So 0 is a rational number. If you have any doubt, what we have to do is we have to quickly recall what is the definition of a rational number. So rational number will be in the form of p by q, where p and q are integers. So 0 we can write it in the form of 0 by 1, right? In this case, this is an integer, this is also an integer, and the denominator is not equal to 0. So 0 follows all the rules which define what is a rational number. Fine. We move to the next problem. That is, find 6 rational numbers between 3 and 4. Now in the question it is not given which methodology to use. So we are free to use whatever methods that we want to do. Okay. And personally I prefer solution 2 because that is much easier. And so I will now do it in method using solution 2. Okay. So in this case we need 6 rational numbers. So the denominator and the numerator should be multiplied by the factor 6 plus 1. So let us first represent the left and right boundary or the extreme numbers in the form of a fractional form. So we have r equal to 3 and s equal to 4. Okay. So the 3 we can multiply by 6 plus 1 divided by 6 plus 1. Okay. And then we have numbers in between. The other number is 4. 4 I will transform again using the same numerator and denominator, that is 4 into 6 plus 1 divided by 6 plus 1. Okay. So when we calculate, you will have 3 into 6 plus 1, that is 3 into 7 or 21 by 7. And similarly the other number, you will have 4 into 7, which is 28 by 7. Okay. So if I explicitly write all the numbers, we can write it as 21 by 7, which is the first boundary, then 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7, and 28 by 7. So these are the 6 rational numbers between 3 and 4. Okay. So much faster than finding using r plus s by 2. We will have so many individual multiplications and calculations to be performed. This is a much faster way. Let's move to the next question. That is, find 5 rational numbers between 3 by 5 and 4 by 5. In this case, I will solve the problem using both the solution methodologies, that is solution 1 and solution 2, because till now we were only dealing with r and s as integers, but this time we have r and s as a fraction, right? 3 by 5 and 4 by 5. So we have r equal to 3 by 5 and s equal to 4 by 5. So let us first solve the same problem using solution 1, that is r plus s by 2. So r plus s by 2, let us find the first number, r plus s by 2, and I can write it as 3 by 5 plus 4 by 5 by 2, and you calculate, you will get 7 by 10. Second number, I can keep the same r, and for the s I will use this. So r plus s by 2, the new r is 3 by 5 plus 7 by 10 by 2, and if you calculate, you will get 13 by 20. For third number, I will keep the same r and I will update s as this, so that at least one r is simple. 3 by 5 plus 13 by 20 by 2 will get 25 by 40. For fourth number, I will use R as 7 by 10 and S as 4 by 5. You will get 15 by 20. For the fifth number, I will use R as 15 by 20 and S as 4 by 5. So we can write it as 15 by 20 plus 4 by 5 divided by 2, and if you calculate, you will get 31 by 40. So we have 1, 2, 3, 4 and 5 rational numbers between 3 by 5 and 4 by 5. So using solution 1 methodology, we have calculated the 5 rational numbers between 3 by 5 and 4 by 5, and you have the correct answer with you now. Okay, now as I said before in the previous lecture, the choice of R and S, okay, when you are doing this, finding the first rational number will be easy because we have both R and S as simple number, but in the next steps of calculating the additional rational numbers, we have to be careful with the choice of R and S. It is wiser to go with a simpler R or simpler S as much as possible, because smaller R and smaller S means we will have multiplication using simpler numbers, not big numbers. Now, even though it is not asked in this question, I will now calculate what will be the actual values of these fractions, okay, because this knowledge will be useful later in the class. And what was this R and S value? 3 by 5 is nothing but 0.6 and 4 by 5 is nothing but 0.8. Now you can note that all these fractions are complete, right? There is no doubt or difficulty in representing these numbers in the decimal form. Okay, so for the moment you just keep this knowledge with you. Later we will make use of it. So I will also solve the same problem with solution 2 methodology now, and we will see how we can find all the rational numbers in one single step. So we have again R as 3 by 5 and S is 4 by 5. Okay, and we have to find 5 rational numbers between the two. That means we will have to multiply the numerator and denominator by 5 plus 1. So let us write it. The first number 3 by 5, okay, I multiply by 5 plus 1 and I will also divide by 5 plus 1, okay, and the other number is 4 by 5, I will multiply it by 5 plus 1 and I will divide by 5 plus 1. So now if we calculate, minus 3 into 5 plus 1 is nothing but 3 into 6 or 18 divided by 5 into 5 plus 1 is 5 into 6, and that will come to be 30. And the other number is 4 into 5 plus 1 or 4 into 6, you will have 24 divided by 5 into 5 plus 1 or 5 into 6, 30. Now we can write all the numbers in between, that is 18 by 30, and next number I can write it as 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30 and 24 by 30. So we have 1, 2, 3, 4, 5. 5 numbers between R and S. So if anybody has any doubt or difficulty in doing this 5 plus 1 with the previous problem, you can understand that even with fractions, this method is much faster. You will have to do few multiplications here and there, but that is it. Once you find the two extreme numbers, then finding the other whatever be the number of numbers that you need, it is a much faster approach. Now we move to the fourth question. State whether the following statements are true or false. Give reasons for your answers. The first statement is every natural number is a whole number. So what are natural numbers? So natural numbers are represented by the letter capital N, and we have numbers starting from 1, 2, 3, 4, and it goes all the way up till positive infinity. Okay, so every number in this particular set of natural number 1, 2, 3, it is also a whole number. Why? What is a set of whole numbers? Whole numbers are represented by the capital letter W, and we have starting from 0, then 1, 2, 3, and it goes all the way up till infinity. So we have all the natural numbers plus 0, we will get whole number. So every natural number is also a whole number. So the answer to the first question is true. The second question is every integer is a whole number. So let us write what are integers. So integers are represented by the letter Z, capital Z, and we have numbers starting from negative infinity. Okay, and we have many numbers. Let's write -2, -1, 0, 1, 2, 3, and it goes all the way up till positive infinity. And we know what are whole numbers, right? So whole numbers are all these numbers. So we have 0, 1, 2, 3, and all up till positive infinity is the whole number. But when we look at the set of integers, we also have negative numbers. So if I take, let's say, -2, -2 is an integer, but it is not a whole number, right? -2 will not belong in the set W. So the answer to the question is, it is false. Now third question, every rational number is a whole number. So let us write what is a set of rational numbers. So set of rational numbers are represented by the capital letter Q. It will start from negative infinity. We will have negative numbers, okay, and 0 is there. Then we have positive numbers. Okay, I'm not writing all the numbers, I'm just writing some samples of it. Now the question is every rational number is a whole number. So let us take quickly one rational number and see whether it is a whole number. Okay, let us say we pick 5. Is 5 a rational number? Yes, because 5 can be written as 5 by 1. So it is a rational number, and 5 is also a whole number. But let's say we pick 1 by 2. 1 by 2 is already in the fractional form, okay, but 1 by 2 is not a whole number, right? Whole numbers are only 0 and all the natural numbers. So the answer to the question in this problem is, it is false. Before we move ahead, we can rewrite this knowledge that we have learned as that we can represent every whole number as a rational number, but the vice versa is not true.